Excellent. Welcome. My name is Brenda Staines, Senior Project Director at Reuters Events. Today, I am thrilled to welcome our LiDAR Key Enabler for Safety Autonomy webinar. We have a great group of leaders joining us today. I am going to keep this brief and get into a few housekeeping notes before we start. I would like to bring to your attention the Q&A box on your screen. This is a really important function that allows you to ask questions throughout these 45 minutes. So don't save your questions, make sure you get them in, as we will do first come, first serve basis. So to repeat, that the Q&A box is to ask all your questions to our fantastic panel. My name is Brenda Staines, and without further ado, I would like to hand over to Pete, our host. Welcome, Pete.
Thank you so much, Brenda, and thank you for everyone for tuning in today, and to Reuters for hosting this discussion. Really looking forward to this. For those of you who don't know me, I'm Pete Bigelow, your moderator for the day, senior reporter at the Automotive News, and host of the Shift Mobility podcast. We're talking a lot about LiDAR today, and its position as a key enabler for safe automation and autonomy. Real quick, I'd like to ask our esteemed panelists to introduce themselves. John, why don't we go ahead and start with you?
Thanks, Pete. Good morning, everyone. Currently, I serve as an advisory board member for several technology companies and as an investor for 2 venture capital firms and in 2 SPACs. In July of last year, I retired after a 40-year career from General Motors as Chief Technology Officer and President of GM Ventures, which is the venture capital subsidiary of General Motors. In those 2 roles, I led the organizations that are responsible for advanced technology in General Motors, specifically research and development, which works on advanced safety technologies, battery technologies, and a host of other things. And in GM Ventures, we made a number of equity investments in startup companies that were developing automotive-related technology, including radar, LiDAR, and other types of technologies, again, for active safety. Prior to becoming CTO, I was Vice President for Global Product Planning, Vice President for Global Product Development. I also spent more than 13 years working in GM's international operations in South America and Europe. I started General Motors in the technical organization and had a number of assignments in engineering and vehicle engineering, propulsion system engineering, and so on and so forth.
Great, thanks, John. Jordan, how about you?
Yes, hello, everybody. So I'm Jordan Greene. I'm one of the co-founders of AEye. AEye is a technology company providing LiDAR to the industry, and we work through partners like Continental, who you have here on the line. Before before AEye, I might as well be a Continental employee, but before AEye, I worked in a venture capital firm, and I have a technical and business background with a lot of aerospace and defense focus. So a lot of knowledge, aerospace, defense, sensors, and automotive, and happy to talk to you here today about LiDAR as a key enabler in the autonomous stack.
Great, thanks, Jordan. And last but not least, Gunar.
Thank you, Pete. Yeah, my name is Gunnar Juergens. I have been with Conti for 18 years now, and also 18 years with the automotive industry. I was working in different roles in advanced development, R&D, and also general management. As part of this, I have lived a couple of years in India, long in Germany, where I come from, and now I live in Santa Barbara, California, in the US, where I have taken over the responsibility for the full LiDAR segment and LiDAR business of Continental. I have taken up this role in 2019, based on my passion for safety and intelligent mobility, the 2 topics that will bring us here also into discussion. And prior to this, from my background, my previous responsibility was bringing the driving functions into the market for Continental. So I built up the global team for driving functions, from the safety functions up to automated driving. Thank you. Looking forward.
Great, thanks, Gunnar. Just to set the stage for our audience, we're gonna have a moderated discussion for about 30 minutes, and then we'll take questions for about 15 or thereabout on either side. But just to set the stage for our conversation today, It wasn't all that long ago where automakers were pretty much taking whatever they could get their hands on in terms of LiDAR. Obviously, it was very hard to kind of even manufacture prototypes. This is no longer the case, though, here in April 2021. If I could get a quick overview from each of you, perhaps, and Gunnar, we'll start with you. Where are we today?
Thank you for this introduction. I think we are in a very early stage of a new market development. So we as Conti, we are known as a sensor supplier. We are a market leading in the area of radar. We have a big camera business. So maybe let me compare this to our experience. So we believe LiDAR is still at the beginning of the market introduction. And it's very natural that you would start in a phase one to take whatever you find, right? I believe the market has started where you see applications with multiple different technologies where automotive OEMs basically took what they found in the market. Yeah, that's what we saw in radar maybe 20 years back. I would then say natural follower would be a phase two. I would call it solve the problem. Yeah. After you start with something, you really have to solve the problem. And if I might comment on this one, we get a lot of requests for information, requests for quotation in the area of highway-related safety applications. Whenever there's higher automation and you want to drive hands-free, safety is your utmost target. And here, I would really like to say that this is now where we all have to come together to solve the problem of looking far ahead, solve the problem of making such applications safe. And this is where we are convinced that LiDAR will play an important role. Yeah. The third phase, if I could conclude, is also a natural phase, and this is to reduce cost. Yeah. And this will come after solving the problem.
All right, John or Jordan, John, how about we go to you next? Where are we in terms of getting the cost down to where this is practical to kind of look ahead at the next set of 5-year plans?
Yeah, well, I think, in contrast to camera and radar technology, at least for automotive, both of those technologies are very mature and have been widely deployed, meaning millions and millions of units in both advanced driver assistance systems and autonomous vehicle development. In fact, there are some manufacturers, I won't name them here, but they could tell you that they're on like their 6th generation or 8th generation or 10th generation of radar, for example. And we know that cell phone technology, at least the generic technology, is in millions and millions of units of production every year. So these are widely mature technologies. That's not the case with LiDAR. The benefits of LiDAR technology are well known, dating back to the DARPA Grand Challenge in 2005. But LiDAR sensors haven't really been deployed in high volume production applications because the incumbent technology is complicated, it's bulky, very expensive, measured in the cost of several $1,000s. Now things are changing, and now we're in, let's say, the first, let's call it the first, maybe best 2nd generation of solid state LiDARs that have greater performance, smaller size, solid state componentry, and a cost that's well below $1,000. So in other words, a better SWaPc. SWaPc is size, weight, and power plus cost, which is the reason why a new technology replaces an incumbent one. And this is going to definitely increase the attractiveness of LiDAR for production applications, as well as when we get to deploying autonomous vehicles, you're going to see it show up there as well.
Super. And Jordan, maybe you can pick up the baton there a little bit. John mentioned solid state. Is spinning LiDAR kind of ancient history at this point? What is the state of solid state, and where are we going here in the next few years?
Sure. Yeah, I think it's a great question. And I think solid state is really a function of reliability and scalability and cost curves that are ideal. So what you want to see are components that can scale well with the high volume demands of an automotive market, and accordingly be able to meet the vibration, shock, temperature requirements that you see in automotive. And so in order to do that, solid state is sort of a prerequisite to be able to achieve those things. There are certain examples where, yes, you can achieve certain levels of performance, maybe with a mechanical system, or you might be able to pass some of those harsh environmental testing with a mechanical system. But definitely to get to cost curves relative to that of radar and that of camera, you want to get to a solid state component. And ultimately, you want to reduce the number of components and get it down as far as you can in the exact manner that John was talking about, which is the size, weight, power, cost. And those all go hand in hand. So I think it's really a function of how you design your system to optimize the performance and the cost, and that comes a lot to do with the next generation, which includes solid state technology.
All right, super. Gunar, you mentioned earlier that we have, you're getting a lot of traction in terms of highway applications, and I assume that means high-speed applications as well. I'm curious, does 905 nanometer versus 1550, does that come into play at all in terms of, is one of those more effective or not for those particular applications that seem to be driving some of the growth right now?
I mean, the market demands, they come from those companies who want to solve a problem, as I said earlier, right? And my point was that the big problem that I see now that is really driving the market is the problem of high speed on highways, probably during a hands-free driving. And this is where it's all about high performance in range and distance. So if you drive at high speed, you know this from your own experience, even your own eyes, you kind of focus on what's really out there in your ego lane, maybe adjacent lanes, but it's far away from you. And here you just have these limitations in the current technology with radar and camera. So on LiDAR, what is the right technology to do this? It is, from our point of view, it is the wavelength where you can send as much energy, laser energy, as you can out there while being still eye safety compliant. For us, there's a huge advantage in using 50 nanometer technology.
And I'm happy to play off of that too a little bit.
Please go ahead, Jordan.
Yeah, so I think that there's some fundamental limitations which are just well known and well understood between 900 and 1550. 900 nanometers, what it does is it's very similar to that of a red or green laser pointer, for example, where you have the ability to focus it. Your eye can actually focus it. So it focuses on the retina, and if it's misused, it can cause irreparable damage. That's just because of the inherent characteristics of it and the way that your eyes actually focus it. That being said, what ends up happening is the FDA regulates it heavily in the US, IEC regulates it heavily overseas, because you have to limit the amount of energy that you're putting out into the world, and you have to limit the way in which you actually focus that energy to be able to get around that. The difference between red and green laser pointers and 900 nanometer lasers is that red or green laser pointers, for example, there's a blink reflex. If someone shines a red or green laser pointer into your eye, you look away, you blink, you try to get it out. With 900, it's invisible to the naked eye, so it could be very dangerous if misused. The difference is 1550, on the other hand, doesn't get past the liquid in the front of your eye. It actually doesn't get focused by your eye. So there's a lot more power that you can put into the world, or energy that you can put into the world with a 1550 laser. And it's the reason that you've seen a shift in a lot of different environments like telecom or aerospace and defense, where people predominantly use 1550 based lasers because you can get a much better performance power budget or performance budget out of it. So you have more photons effectively to use with it. And that's why we've moved a lot of technology from 900 to 1550. There are still use cases for 900 nanometers, but you'll find that fundamentally they will be a lower performance system or sensor.
All right, super. Thanks, Jordan. John, I kind of want to emphasize a point that both Jordan and Gunnar have made, and it seems that the economic driving force right now in LiDAR, at least for automotive applications, is for these level 2 plus applications. Is that what you generally see too? And what is the as you put it, the SWaPc formula that works for a level 2 LiDAR? Nope, John, I think you're on mute right now.
Generally speaking, I mean, there's been an interest in having solid state LiDAR, you know, in either active safety or fully autonomous applications. I mean, the cars you see today that are running in development mode with, you know, for fully autonomous typically have several spinning LiDAR sensors on them. They're packaged on the roof. They're out in the open. It's difficult to package those. In fact, it's difficult to package any sort of rotating mirror technology today. And so the idea that you want to reduce the size, the weight, you want to have better packaging. I mean, this applies to almost every application of LiDAR that you can imagine. But specifically on active safety, you know, it really hasn't been a technology that you could afford to actually consider seriously in an active safety system that you wanted to sell in the hundreds of thousands or millions of units. I mean, these are typically systems that are a couple of $1,000s at most. That's a retail price. So you can imagine the material cost of the system. You know, for the rest of the sensors, the LiDAR can't consume the entire cost of the system. There's radars, there's cameras, there's processing. And so LiDAR technology has really been almost cost prohibitive for any kind of a high volume application. Now that you have solid state, now that you have better, you know, SWaPc overall, I mean, now you can seriously consider, okay, can we put a LiDAR on an active safety system? And what sort of capability? How could we increase the performance envelope of our system if we had one on board, probably a forward-facing one, at least as a primary application?
All right, super. Gunnar, this might be a good time to address, and I've seen this question come in already, and it fits right in here. People want to know, do you really need LiDAR for a level 2 or level 2+ system? And you know, how do you see that business shaping up? What do you see your customers telling you that answers that question?
Yeah, thank you for the question. That's certainly a very important question, and it relates to what John has said about the volumes, right? If you want to enter a volume market, you have to come at a certain price performance point, right? We see it in an easy way. As I tried to explain earlier, we believe we're in a phase where we need to bring automotive qualification, automotive robustness in a LiDAR to a market that solves the problem, right? And we don't want to compromise on performance if we want to solve a problem. We had the same experience in our radar business, and we are just about to sell our 100 millionth radar sensor to the automotive industry, by the way. And first of all, these things come at a price, but they must be able to do something other sensors cannot, right? And for LiDAR, for us, this is about resolution in the distance. Now, you can argue, do you need that high performance in level 2+? That's a question the OEM has to answer. And I would say this is a function relative to the speed that you take, right? In level 2, you have the responsibility with the driver. So you wanna tackle that situation at different speeds, and the higher the speed it will get, the more you will have the sensors look into the distance. And the rest is a question of what your product is targeting and what the kind of product concept you have. Definitely on the higher levels of automation and at all higher speeds, we believe LiDAR is inherently more effective than any other sensor. Solving the problem means you make high speed safe, and the moment you get autonomous level 3 and above, it's an absolute must. That's how we see the market.
All right, super.
Pete, the way I think about it is you should use each sensor to its best advantage, okay? There are things that are ideally suited for cameras. For example, I can't imagine a better technology to read a stoplight, whether it's green, yellow, or red, or maybe a speed limit sign, okay? And there's a lot of things that camera technology can do. But let's face it, camera technology is poor in low light conditions. That's where radar and LiDAR come to the forefront. You know, camera technology has its issues with measuring distance. I don't care if you have stereo cameras, you're not going to be as accurate as having a LiDAR on board. And as Gunnar mentioned, at higher speeds, measuring the distance quite precisely becomes more of a consideration. I won't go through the whole list of what each sensor does well, but I will tell you, it's, you know, this whole discussion of which sensor is the only one that you need, for me, is a little ridiculous. It's kind of like the discussion that we have about mass reduction in cars. People argue all day long whether it's better to have a steel car, an aluminum car, a carbon fiber car, you know, a magnesium car. And the answer is use each material to its best advantage. And like in an analogous way, we should be using sensors to their best advantage.
All right. Speaking of this idea of mass production, I know that we've seen you know, a lot of contracts for mass production of LiDAR from a variety of companies that have partnered with each other. We've seen quite a few delays in those blueprints. So Jordan, I'm wondering if you can tell us a little bit about, you know, from your vantage point, what does it really take? What does a healthy partnership look like? What does it take to take this technology and really transform it into a product where we're talking about making millions of units?
Sure, and speaking from, I guess, lots of painful experience, I would say since the beginning of the company back in 2013, we have been of the mindset that we will never be able to recreate the manufacturing excellence of a contract manufacturer or a tier one. It is a large undertaking that, for example, someone like Continental has been doing for 150 years with resources and exposure to various different levels of quality, validation, testing, and the ability and the trust that they have with the customers to be able to deliver on those types of quality products that have to live for 15 years beyond the last year of production, which means 25 plus years. And it's a massive undertaking to go through that level of rigor, to go through the steps that it takes to get through a B sample, a C sample, and get all the way through PPAP. It is something that we've found that we are a complementary provider or technology provider to our tier one partners, such as Continental, to be able to provide a reference architecture, our software, which has a very novel design, but really leverage the well understood manufacturing principles and practices that Continental has been using for so long to be able to actually deliver on something of that quality. And I think that's really, really key. And so when Continental signs up to deliver a product on a certain schedule for a specific start of production, they will do it, and they will do it with a certain level of guaranteed quality that the customers know and trust, that the OEM customers know and trust. And I think that's really, really important. And it's the reason that we've taken this harmonious approach to saying we have a lot of novel technology designs. We have a lot of know-how out of how to make a product that is second to none in performance and cost, in reliability. But when we hand it over and work with our tier one partner and we say, here's the reference architecture, we trust in them to help us industrialize and set up the manufacturing to deliver on those extremely high volumes for those series production programs.
All right, thank you.
Maybe Pete, if I can add to this,
yeah,
speaking
please.
specifically now about our partnership, what I like is we really have a common goal, yeah, and we really have a passion for this product, and that's creating a connection that is absolutely necessary to drive this everyday collaboration. Yeah, we have a team spirit. You need this cultural openness to cooperate, yeah, and to overcome this not invented here syndrome that you have in any engineering, in any location, even in any company. And what helps is you need to have that complementary expertise. Yes, you have to look up to the other, respect for what they have done and what they will be able to do if you cooperate in the right way. And this is how it blends perfectly together here.
We talked earlier about the evolution of LiDAR, and looking forward a little bit, I want to ask you about this phrase that I keep hearing, more and more these days, and it is software-defined LiDAR. Jordan, what exactly does that mean, and what can you configure with the increasing role of software?
Sure. Yeah, it's a really good question. I think software definable gets used a lot now, and realistically, there's a lot of different ways to I guess coin the phrase or to actually explain what it means. But within the construct of our solution, what it really means is it's the ability to behave similar to that of the eyes and the visual cortex, to be able to use it to adapt to varying different environments, so that if you're in a truck versus a passenger vehicle versus a shuttle versus anything else, you can reconfigure the way you're addressing the world. And you can do it at a fundamental level at design time. So you're accounting for things like maybe where you're mounting it in the vehicle, maybe the fact that you're addressing a certain application like highway autopilot versus city driving, or very much maybe you're just accounting for the tolerance and the calibration that you need to go online. And so we have the ability to configure our sensor in software to account for all of those things: the tolerance, the use case, the vehicle itself, the mounting location, and be able to actually address all of that. But also at runtime, we still have the ability to influence it. We have the ability to trigger based on things like if we speed up, we can fundamentally change the way we approach the world, just as you would as a human. You're driving down the street and you merge onto the freeway. You want to approach the world a bit differently now that you're in a high-speed environment. You want to look much further down the road. You're less concerned with maybe things right next to your vehicle because you're going 60, 70 miles an hour, and you need to see very long distances and see maybe small objects on the road that you need to account for. And that's what we enable. We enable the ability to dynamically address your environment. And that's what we believe is software configurability. It's not just the ability to change your field of view or maybe change your resolution a bit. It's your ability to fundamentally change the way you approach the world, given the vehicle, given the application, and ultimately given the environment.
All right, thanks, Jordan. John, what does that mean in terms of what does that versatility provide, and how does it fundamentally change perhaps how you want to configure your system? Can you use fewer sensors, for an example?
Yeah, hey, and the ability to be able to command a sensor to change the way it's scanning the environment is a big deal. I mean, typically the rotating mirrors that you have today swing around. They have somewhere between 16 and 128 separate beams, okay? And they just capture everything in the environment as they swing around, okay? To the extent that you could have a sensor that you would have in, let's call it a wide field of view mode, scanning the environment, and then when it detects an object of interest, it zooms in. That's a pretty excellent capability to have. And the so what is, you don't need so many different sensors, short, medium, and long range, left, right, and center, and so on and so forth. And that cuts down on the processing power that you need as well, because these sensors consume processing power. And every time you add another sensor, the amount of processing power just goes up. And in the case you have redundant processing power for safety reasons, here we go. So, the idea that you can get more capability from each sensor is a really excellent approach to have in terms of building a system that does what you want it to do.
Are we at a point where, there was a point where you wanted as much processing power as possible just so you can be prepared for, a variety of configurations? Are automakers starting to button that up and say, know exactly what the spec is that they want and not want to pay for power beyond that?
Well, let's talk about LiDAR specifically. I mean, I think there's pretty wide agreement. I mean, they haven't actually swapped notes in the past with each and every automaker. We typically don't do that for antitrust reasons. But, you know, when you look at, you know, sort of the kinds of things that people want to do, okay, it's clearly, you know, a range for the LiDAR of at least 250, and most would say at least 300 meters. That's derived from use cases like making an unprotected left turn. How many seconds does it take to make an unprotected left turn? And how far down the road do you have to sense a vehicle to avoid a collision, right? So, you know, 300 meters of range, you know, reflectivity criteria, resolution criteria, and so on and so forth. I think those are relatively in the same ballpark for the kind of solid state LiDARs that we're talking about here. I'd say in the past, the Yestertech technology, you pretty much took what you could get, okay, and you made the best that you could of it. You really didn't have a chance to talk about what I like to trade resolution for field of view, for example. I mean, that wasn't sort of a trade that you could make because of the technology that you were talking about. So it opens up a lot more opportunities to really optimize a system.
Looking ahead, please go ahead.
Just to answer, also to add on to what John was saying, I mean, processing power, heat, and latency are all interchangeably connected in a lot of different ways, and it comes into effect fully when you start to introduce the compute that you have to account for to take in all these sensors. If you have, you know, multiple redundant sensors and all these different things, and so ultimately you're trying to reduce the complexity, you're trying to reduce the cost, you're trying to reduce the power, the heat, and the latency associated with it, and ultimately trying to create sensors that are smarter or that have more flexibility could reduce your overall sensor count, as John said, and be able to allow you to circumvent a lot of those negative externalities.
I want to piggyback on something John mentioned earlier about, you know, kind of maximizing each sensor to its fullest capability. Gunnar, I'm curious if, you know, from your vantage point, you see a lot of different sensors, and we know there's a lot of novel advances with radar and cameras. So do you see a day on the horizon where LiDAR is obsolete?
Yeah, that's a good question. I come from the driving function side, and let me be very pragmatic, and let's put ourselves into the driver's seat. And I'm with John. It's not a principal discussion here. It's not a principal question. It's a matter of what you want to do with it. Yeah. Put yourself into the driver's seat. You have a fancy car, does everything well with radar and camera, and then you drive into the night, and maybe the lighting of the street is just not good anymore. Your driver assistance systems will then degrade, and finally it will say, hey, it's you who's steering, right? Because a camera cannot see in the night. You can optimize it. Cameras will get better and better, better resolution, all of this, but you cannot substitute daylight. A LiDAR comes with its own light, so you illuminate the scene wherever, whenever you are there. A night is not a problem for a LiDAR. For the best camera, this will remain a problem forever. Next situation, I don't know, maybe you have driven through the Alps in Switzerland, right? Again, you have the most expensive car with a beautiful driver assistance system. Then you enter a tunnel, and you happen to be in a situation of a day where the daylight is shining right into the tunnel the moment you exit it. It's just blinding you, right? The radar is kind of limited in the tunnel because there are so many reflecting surfaces, and then the camera is blinded by the sun. What do? Again, your system will degrade, and no matter how expensive your car is, it will say, hey, it's you who's driving, please take over, right? If you have a LiDAR, the tunnel or the light blinding is no issue because the physics is just different. You have your own light source in the LiDAR, you illuminate a scene wherever you are, and every pixel you generate has a distance. So a LiDAR can bring you through those situations safe, independent from the level of automation your car is. and there will always be a difference in physics.
All right.
I hope that answers your question.
It definitely does. And I may ask one more before we start getting to questions for our audience. Jordan, there's obviously a lot of LiDAR companies out there, and I'm sure you have a particular viewpoint on this, but how do the ones that will still be standing in 5 years separate themselves from the ones that will not?
Sure. And I think I'll approach this question in a few different ways, because the technology question is often the question that gets asked to me the most, which is, which technology is going to win out? And I usually answer that, how many cameras do you have currently in your life, and how many cameras have you had in your life, right? And the answer is usually a lot. You have cameras on your phone, you have cameras on your iPad, you have cameras in your car, you have cameras in your computer, you have cameras all over. And so if you believe that LiDAR is going to be in everything because of the reasons that Gunnar and John said, which is that it is a 3D data set, it gives you resolution at range, it's independent of lighting conditions, it adds significant value where you can actually measure 3D information, not just interpolate, but measure 3D information. It is a really powerful tool that will be used in a lot of applications. And there's a lot of different ways to approach it. We have taken the mindset, especially at AEye, that we're not evangelists about any type of technology. We utilize what we consider to be best of breed technology. We utilize the highest performance solutions that in this case, in this embodiment, you have 1550 base laser technology coupled with a bistatic design with a focal plane array that has the ability to behave similar to that of a camera imager or a camera chip that is divided up into thousands of elements. And a MEMS-based scanner, which is an extremely small MEMS that are the size of if you took a pencil and you touch them to the tip of a piece of paper, touch the tip to a piece of paper, you looked at the dot, that's the size of them. We picked those because we looked at the supply chain and we said, we need to find robust technology that can be produced by tier 2 suppliers, and then providing the reference design to that of someone like Continental, who can manufacture and actually bring it all together. And so we see a lot of value for a lot of the different LiDAR technologies that exist in the market. And we see as they mature, we'll continue to evaluate whether or not we will use them in our solution. So to answer the technology side of the equation, we think that there is a lot of opportunity for a lot of different technologies to emerge. And we actually bank on the fact that the technology evolution cycle is increasing and new technology is emerging into the LiDAR space. And so we're excited by all of those developments. Simultaneously, I'd say when you look at the way that you approach the market, the way that you approach a business model within the market, you're looking to do things that John and Gunnar have accurately said, which is drive for size, weight, power, cost optimization, and reliability. And that's really, really key. And so if you have a technology that scales, that today is of a solid state nature, is of that exact profile, right? Size optimized, weight optimized, power optimized, cost optimized. And then you're, in our case, for example, selling through channel, you have the ability to be able to be relevant in the future because you're going to need the level of reliability and quality for nearly every different market that Continental can provide. And so our whole thesis has been, if you are providing a technology that meets those performance criteria and is within that profile that I just discussed, and you're selling through channel, you have a really, really good opportunity to be able to survive and be successful in the market. And that's really what I look as my criteria for who's going to be around. That's not to say that there's not a lot of great technology. There's a lot of different ways to approach the LiDAR problem. And so I'm excited to see how the market sort of weeds itself out.
All right, super. John, do you want to add some perspective from an automaker perspective on what wins out over the next few years?
Well, I think there are a lot of, I don't want to turn this into a technical discussion about who's got what, but I would say that being able to manufacture at scale is a huge, big deal. Look, we don't want a system that just works, okay? This thing has to have 99.9999% reliability, and that means that every sensor is more or less identical to the one that came off the line in front of it, okay? And the reason why you need that is auto works in the law of large numbers. We build 100 million, round numbers, 100 million vehicles a year, okay? At 100 million vehicles, if you only have 99% reliability, you've got a massive tail of problems, okay? Just because of the law of large numbers, okay? 99% times 100 million, okay? Multiply that by a number of years and you've got a staggeringly large number. And so the idea that these things are available, the technology is available, is great, but they have to be scaled, and they have to have not just, you know, sort of a bar that they work, they have to be flawless, okay? Because we're talking about safety systems here, not, you know, some app that misfires on your phone and you got to reboot your phone. We're talking about safety systems that our families and our friends are riding around in vehicles that have these systems. And so having a level that is, for all intents and purposes, flawless is sort of what an automotive OEM wants to have.
All right, that seems like a perfect encapsulation of what you know, LiDAR enables in terms of safety. So why don't we go to some of the questions we have from the audience in the few minutes we have left, and maybe we'll kind of go lightning round on some of these, because we have some good questions. And maybe we'll start with this one, and it's a good one, and we touched on it a little bit before, but will LiDAR be positioned on top of the cars, or is there flexibility in terms of where you can put them? And Gunar, why don't we have you answer that one?
I think if we talk about a mass volume market, LiDAR has to be absolutely flexible with regards to the positioning. The reason is nobody wants to have a hat on the car that looks like a police, even if it's not. It is the OEM at the end deciding on the design of the car, and they will say, I would prefer the LiDAR that can be built inside of the car so that people don't even see it. Look at the radar and camera integration and how you can hardly see them nowadays. This is the way to go for LiDAR.
Great.
The more flexibility you have, the more you will sell. That's our equation.
All right, perfect. Thanks, Gunnar. Feeding into that, John, where do we put them on cars, and how do we keep LiDAR clean?
Well, I think Gunnar hit on it. I mean, you know, there's obviously, we call it the mirror farm, okay? Right behind the rear view mirror on the inside of the car, there's a lot of sensors that wind up in that mirror farm. But potentially you could put them into behind the headlamps, you know what I mean? Behind the headlamp covering, alongside of a headlamp. You know, if they're small enough, there are lots of places that you can integrate these things around the vehicle. The problem is you can't integrate something that has to swing around in a 360-degree circle unless it's sitting on the roof of the car, right? And so, you know, the ability to reduce the size massively, to be able to get them to the point where you can put them behind glass, okay, whether that's windshield glass or whether that's a piece of headlamp covering, that's the way to go. You ask about, you know, how do you keep them clean? Well, that's the way you keep them clean as well, because you've got headlamp washers, you've got windshield washers, and so on and so forth. In some of the development vehicles that we've done over the past, we had very elaborate systems that used water and compressed air to try to keep all of the sensors that were outside the vehicle clean. And that's not something that you want to do in a high volume application, which is, you know, to create an entire washer system for all sorts of little sensors around the car that could get somehow mud, dirt, bugs, whatever it is that could degrade the quality of the sensor. All
right, super. Jordan, at the outset, you mentioned that you have previously worked in aerospace and defense, so maybe this last question is perfect for you. Outside of the automotive sector, what new LiDAR applications will we see in the next few years? Will we see LiDAR further integrated into smartphones?
Yeah, absolutely. I think that there's going to be a need for LiDAR. And this was my what I was saying before, which is I believe that LiDAR is a secular trend. And there's a lot of different ways to approach the LiDAR product. You know, the LiDAR demands. The consumer applications are definitely one very large market that some people may focus on. And there's different needs for it, right? If you want a very, very short range, very low performance solution for your iPhone or your iPad, what it'll do is it's like a rangefinder, and it tells you how close the object is to help take a photo and to be able to pick apart that person from the background behind them. And so that's been an implementation that has been obviously getting a lot of press and news recently, because it's an implementation of LiDAR that has a very large market, but it's a very low performance solution, or it's a very low cost, low performance solution that needs to be addressed. Simultaneously, there's a lot of markets that need high performance, long range LiDAR, and those span everything from things like commercial vehicle applications, so trucking, also construction and mining, intelligent transportation systems or traffic systems, which are applications where you put it up in cities to help with throughput, so that you can have less congestion, you can get cars in and out, you can have less accidents, especially in times where you have dense populations leaving work in city environments and so on. And then there's a lot of others. There's aerospace and defense, there's drones, there's a lot of different needs for LiDAR, because as I said, if you imagine where camera is, or where video and video camera is today, what you would say is there a reason, is there value for adding the 3D data set? And usually the answer is yes. And there's no evangelist argument about if cameras are better than LiDAR or LiDAR is better than camera. John and Gunnar have both said it really well. LiDAR is just an additive sensor. That's like me asking you, is your hearing better, or your sight better, or your smell better? Like, which would you prefer? And you'd say, I want all of them. And you'd go, great. That's the same thing. We think the same thing. And so LiDAR is just a 3D data set that's complementary to camera and radar. And so where you see cameras and radar today, you'll ultimately see LiDAR at the right performance and the right price.
All right, perfect. Jordan, thank you. Gunnar and John, thank you as well. Great discussion this morning. I'm sorry that we didn't get to all the questions in the queue, but Brenda, as I hand it back to you, there's one perhaps that you can best answer, and it is, there's members of the audience wondering, will they get a copy of this presentation and points of contact for the speakers?
Yeah, definitely. I'm going to send the recordings next week. And I mean, if anyone has any questions or want to contact any of the speakers, I'm going to post my email in the chat. So please feel free to just send me your questions and I can forward them to any of the speakers. And thank you very much for everyone to joining us. It was a great discussion. We have lots of questions. I wish we had more time. And well, thanks everyone for joining again. Enjoy the rest of your day or evening, and see you next time for more Reuters Events automotive content.